Today we want to talk about buttons. Now in your toolkit, hopefully you have it there, you can look in it, you should be able to see that you have one of these little things. This is a button switch. See if I can get a better view of it for you. The way this works is it has four legs, but these legs are the same pin and these legs are the same pin. When you press the button, you make a connection, just like an ordinary switch that you might have seen in electronics, from one side to the other. So that just makes a conducting path, no conducting path when you're not pressing. You can take your board and plug it into your board, but it doesn't always go in very well. As a matter of fact, it's kind of a bit of a nuisance. And the way it is, you also need some resistors to wire this up properly to correctly use it as a digital input for your board. So we've also given you one of these. There's a diagram in your book that explains the choice of the resistors that we have here. So there's two little resistors, right? See if we can get the focus on that. There we go. Two little resistors on this little piece of circuit board. And on this side, we've got two sets of pins. These go into power and ground. They're just there to make a nice snug fit. And this is the signal pin. So let's actually put the button into the board. Now, it's very important that you put it on this side of the board. The polarity of power and ground on this side, the other side of the board, is reversed to the way we need it. So if I plug my button here, when I press the button it goes high when I need it to. If I plug it on the other side, it won't work. So here's my button. Here's the signal pin right here. And for my convenience, just to show that in fact that this works, is I've got an LED. I'm going to plug this in here, make sure it's in the right pin, and when I press, make sure everything's in the right place, and I press, nothing works. Had the LED in backwards. Now it works. Okay, so I press the button, the LED works, because now I have a circuit from 5 through a 200 ohm resistor to the LED to ground. When it's open, this end is low and the other end is low, so it doesn't light up. Thank you. So here's a figure from chapter 8 of the course notebook. Shows you what this little button circuit is like. Here's our little button, and its purpose is to make a contact, a conducting path. This end is the power line. This end is the ground. Okay? And there's two resistors here. A small one of about 200 ohms. And a larger one of 10,000 ohms, 10 kilo ohms. Now the purpose of this is that when the button is opened, the pin is connected to ground, so it's definitely at 0 volts. When I press this button, I've connected the power in. Now the power can go two ways, down to ground or into the pin. Into the pin is the signal that we're sensing. The input tends to be a large resistance. So since this is a small resistance, the voltage going in is pretty close to this 3.3 volts, and so it'll read high. If I didn't have any connections here, we would say this pin was floating, and any sort of external noise could send it high or low. It would be reading randomly. Even your body's electric field could change what it read. This ties it to ground when it's not in use, and definitely gives you a high voltage when you want it. So here is some code to try and show how we use a digital input, the simplest form of digital input. At the first, I've configured the USART and used clear putty to clear the screen, because what I want to do is I want to show the effects of pressing the button, and I'm going to use that by using putty. So here's the important code right here. Okay, tris-C bits RC3. So this is referring to pin 14, RC3. By setting this guy to 1, we've made it a digital input. Here's RC4, which is set as a digital output, pin 15. So I could have a button on RC3, and I could have an LED on pin 15, RC4. And that's what I've actually done on my board. Now down here is we need to monitor RC3. It's the input. We need to find out about the input by seeing if RC3, the port value, is equivalent to 1. If it's 1, it means the button is pressed. And so that I can see it on a board as well, I have an LED attached to RC4, so it'll turn on when the button is pressed. If that's not true, the button is not pressed, in other words, we print this message and the LED will be off. So this is compiled already and put on the pick. So let's look up here, and you can see, now pressing the button, and it's very quickly reading button is not pressed. I press the button, my LED lights up, LED is off, LED is on. Okay? So that's working. This is not exactly the greatest sort of program here, that it's always printing this message out. It'd be nice if we could actually have it do it just once when I pressed or when I released. That's called toggling, and we'll talk about that next. Now, most of the time when you use a switch, you might think of something like a light switch. You flip the switch and the light's on. You don't have to keep your finger on the light switch to keep the lights on. That sort of behavior is called toggling. And just to show you what we mean, here's the button signal. It's digital. The button is either on or off. What we want to happen is when we press the button, we want the behavior to continue, say a light being on, until the next time we press a button. And then the next time after that, it comes back on and off and so on. This rise is called a rising edge. It's where the signal goes from low to high. This side is called a falling edge, where the signal goes from high to low. So what we need is some code that looks at the signal and finds the changes in the button status, not what the button status currently is. So we've been saying the previous version of this program continuously was printing out button is pressed or the button is not pressed. That's not something we need to do. You generally press the button. If it just says it's pressed, that's great. Now, the way we do that is in a library called buttons.c. There's a function called monitor switch 1 for edges, and you tell it which pin you're going to talk about. Okay. Let's find that and have a look at it. It's in here. It says it will return a 0 if no edge has happened, and it returns a 1 if there's a rising edge. That's a button press. 2 would be when a falling edge happens when you release the button. So in this program now, we've got a constant, has switch 1 changed, which we've defined up here, and it's looking at this switch. And in the while loop, it continually is looking at this. If it's 1, we're going to get button is pressed and turn the LED on while it's pressed. And if it's off, we do this. Right? Now, the way this program is written, you should, before this, have the default that it's not pressed and that the LED is off. So let's have a look at the function. Okay. So I press the button, it's pressed, release, press, release, press and hold, 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 release, 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 press again. That's a little better behavior when you're using something like putty. Now this behavior still has a few things that might not be good for working with LEDs, but it's fine for working with putty. So here we are again. We're looking at this circuit board. And one of the things that we want is to make the button act as if it's a light switch. You press the light switch, the light comes on. Press the light switch again, the light goes off. I want it to do this. Right? Press once, the LED is on. Press again, the LED goes off. On, off, on, off. How would we change the code we have to make that work? Turns out to be fairly simple with this monitor switch 1 function that we have. Okay, so how do we make the LED act like a light bulb and a light switch? Well, it turns out it's very simple. In the while 1 loop, we have monitor switch 1 for edges, right? And if it's changed, we want the LED to say it's pressed. But we also want the LED itself to change. So, very simple piece of code in here. If the LED is off, turn it on. Otherwise, if it's on, turn it off. That's all we have to do to make the LED to act like a switch, not like a switch, like a light bulb, as if it was responding to a light bulb input.